Hello and welcome everyone. Myself Vinay Yadav, mathematics mentor. Hope you guys are doing amazing. So today we are going to have our discussions on the topic orthocenter and circumcenter, as well as we will have our discussions on the topic finding area of triangle, provided we will be having coordinates of a triangle. So in previous classes we have already discussed about incenter and centroid of a triangle. So now we are going to discuss some more points, some more important points related to triangle that we must be aware of. So taking the topic orthocenter first of all. So we are here to discuss about orthocenter. What does the definition says for orthocenter? The definition is very much clear. Once we are clear with the definition, then only we can be able to apply the definitions in our problems. So what orthocenter says is, let's say we have a triangle. Let's say we have a triangle ABC, triangle ABC. So let me write the definition for orthocenter. It is the point of intersection of altitudes of a triangle. So what does this mean is, it is the point of intersection of altitudes of a triangle. So in triangle ABC we can draw three altitudes from all the three vertices. For example, we can draw altitudes from point A in such a way that it will create 90 degree with side length BC. Similarly, we can draw altitudes from point B to side length AC in such a way that it will create 90 degree with the side length AC. So let's say we are drawing here, let's say it is D and this point, let's say it is E. So what does this mean is, here we are drawing altitudes from point A to the side length BC. Now we got the AD is perpendicular to BC. So we got the point of intersection here. So we will give is at the name as orthocenter. So we will give it as O. Similarly, if we will draw altitudes from point C towards side length AB, it will also move from point O itself. Now it will be 90 degree and it will also move from point O, and this point of intersection is known as orthocenter. So what does orthocenter mean is, it is the point of intersection of altitudes of a triangle. So whenever we will draw any altitudes from point A to the side length BC, and similarly we will draw altitudes from point B to the side length AC, it will intersect at a point O, and that point O will be known as orthocenter. So definition is very much clear to you. So if you need to find the point of if you need to find orthocenter in any triangle ABC, so we will not using any formula, we will not go for the formula or derivation anything, because we will use application of straight lines to find the orthocenter. We will not be having any formula. What we will do is, we will be knowing later on, we will study how to find the equations of what straight lines. We will use that concept here to find orthocenter. What we will do is, we will see the logic and the more problems later on. Now only we are discussing about the definition part. So what we will do is, we will be having straight lines equations for side length, let's say BC, and we know the point of coordinates of point A. We will draw straight lines perpendicular to side length BC. Similarly, we will be having coordinates B, and we know the straight lines equation AC. So we will draw a straight line BE passing through vertex B, and it is perpendicular to side length AC. So we can get the point of intersection of two straight lines. So we will discuss these things later on. So right now we have discussed the formula for orthocenter. Similarly, we will discuss circumcenter also. So for circumcenter, let me change the topic. So for circumcenter, it is the point of intersection of perpendicular bisectors of a triangle. So we will remove this word altitudes. Here we can write perpendicular bisectors of a triangle. Perpendicular bisectors of a triangle. So this is perpendicular bisectors. So what does this signifies is, we will see here. Let's say we have a triangle ABC. Now when saying perpendicular bisectors, bisectors word itself signifies that it will be the midpoint of side length BC. Let's say we are drawing perpendicular bisector for side length BC. Similarly, we will be drawing perpendicular bisectors for side length AC. Similarly, we will be drawing perpendicular bisectors for side length AB as well. So here For drawing perpendicular bisectors for side length BC, we will first find the midpoint of side length BC. Suppose this is the midpoint for side length BC. Now we need to draw perpendicular passing through this point. So let's say, just a second, this is the side length BC. We find the midpoint. Now we are drawing perpendicular passing through this midpoint. Let's say midpoint is D. So we got the perpendicular bisectors for side length BC. Similarly, we will draw one more perpendicular bisectors, let's say for or in AB or in AC. So because we need to find the point of intersection, to find point of intersection we need at least two straight lines. So let's say for we are drawing perpendicular bisector for side length AC, we will find the midpoint. Let's say this is the midpoint. Now we will draw the perpendicular passing through this midpoint. So let's say this is the perpendicular, let's say, and this is name is E. So we got the point of intersection as this, so we will name it as C. So let's say this is C dash. So this C is the circumcenter for triangle AB C dash. How we have find the perpendicular bisectors for all the side lengths, let's say for BC and AC. Now we got the point of intersection, and that point of intersection will be known as circumcenter. Similarly, we can draw perpendicular bisector for AB also. For so it will also pass through this point only. So basically this BD is equals to DC dash. Similarly, EC dash equals to EA, EC dash equals to EA, and in the same manner B, let's say this is F, so BF is equals to FA. Now we have got definition for circumcenter also. Problem based on circumcenter as well as more concepts will be discussed after we have studied after we will study equations of straight lines, because we will not discuss formula here or any other thing. We will directly use the applications of straight lines to find the circumcenter. What we will do is we will find the equations for, suppose we have the coordinates for ABC, and we have if we know the coordinates of B and C dash, we can write the equations for this. Similarly, we can find the midpoint also, and afterwards we can write the straight line which is passing through point D and it is perpendicular to side length BC dash. In the same manner, we can find another perpendicular bisector, and after finding two perpendicular bisectors, we can find the point of intersection of those two perpendicular bisectors to find the circumcenter. This is going to be very much easier when we will discuss straight lines equations. Afterwards, we will take the problems based on this circumcenter. So as of now, we have gone through the definitions of orthocenter and circumcenter. Now we will discuss another topic, that is finding area of triangle, provided that we have been given three coordinates, all the three coordinates of a triangle. So in that case, how we can find the area of triangle, we will see it. So let's see here, we need to find the area of triangle. Area of triangle. So we have been given 3 points. So let's say we have, let me draw this to the left side, sorry, to the right side. So we have been given triangle ABC, triangle A, B and C, and we have been provided coordinates of all the 3 points. So coordinates are, let's say, x1 comma y1, x2 comma y2, and C is x3 comma y3. This is x2 comma y2. So what we will do is, we need to find the area of triangle A, B and C. So what we will do to derive the formula, we will just draw, now we will extend B to the point B dash, we will extend point A to A dash on x-axis, this is y-axis. We will take the foot of perpendicular, we will not coin this word, we will take we'll extend C to C dash here. So basically what we have done is, now we need to find the area of triangle ABC, area of triangle A, B and C. How we will achieve is, we will do one thing, that if we will be able to find the area of this much figure, B, B dash, A, so this is going to be kind of quadrilateral, a special quadrilateral named as trapezium. So, just to recall, trapezium is a quadrilateral which is having 2 parallel sides and two non-parallel sides. It can be two non-parallel sides. So because basically we have one side length, one pair of side length which are parallel to each other. In this case, BB dash is parallel to A dash A. Similarly, the figure A dash C A is also another quadrilateral, which is also a trapezium because we are having a pair of opposite sides which are parallel to each other. And we know the formula of area of trapezium. Let me write area of trapezium because we will use it in this derivation. Area of trapezium, this is going to be half into sum of parallel sides multiplied by height. Sum of parallel sides, for example, if we need to find the area of trapezium B dash B A dash, so what we will do is we will need to find sum of parallel sides. What are those sides? B dash is parallel to A dash, so we need to find the length of B dash plus length of A dash. Similarly, in this case, A dash, C and A, we will be required to find the side length A dash plus C. Afterwards, we can multiply with height. For in this case, we have height. The difference between the length B dash A dash is the height is going to be the height for this trapezium. Similarly, A dash C dash is going to be height for trapezium A dash C A. So now, if we need to find the area of triangle ABC, let me state the reason. This is what we require. We need to find this area. So how we can write is, we will find the area of first trapezium. We will add area of second trapezium. Afterwards, what we can do is we will subtract the area of B dash B C dash. Let me write here, then only you can be able to understand it very clearly. So if we need to find the area of triangle ABC, area of triangle ABC is going to be area, we will add to area B dash A dash A B. So is equal to area of B dash A dash A B first trapezium, we will add second trapezium also, plus area of second trapezium, that is going to be A dash C A. Now if we will be let me give the first part, second part, and this is third part, this is going to be the fourth part. So what we have done is, we have till now what we have done for area of trapezium B dash A dash A B, we have find the area of first part plus third part clearly. Now we have from second trapezium we have found the area of second region plus fourth part, that is second part plus fourth part. In actual, what we require is, we require first part plus second part. We require area of triangle ABC, which consists of part 1 and part 2. So what we need to subtract is, we need to subtract part 3 and part 4 in order to find the part 1 plus part 2. So if we need to find part 1 plus part 2, what we can do is, we can subtract from here part 3 plus part 4. So this is going to be very much easier for us to understand. So let me again once summarize this concept. So what we have done so far is, we are going to find the area of first trapezium, that is A dash B, which is consisting of part 1 plus part 3. Afterwards, we are adding this area to the second trapezium, that is A dash C A, and which is consisting of the second portion plus fourth part of this region. So basically, first plus third is from first trapezium, second plus fourth from second trapezium, and now we need area of triangle ABC, which is consisting of part 1 plus part 2. So in this case, what we need to do is, we need to subtract part 3 plus part 4. So it's the same thing which we have done here. We have subtracted for portion part 3 plus part 4. So after solving it, we will use this concept only. So we have done this area of first trapezium plus area of second trapezium. What we need to subtract is area of trapezium consisting part 3 plus part 4, and that is B dash B C dash. So basically, we will be subtracting here minus, this is the concept which we are using, minus here I am writing area of B dash B C dash. So I am removing this one to write it clearly. We have seen this concept. Minus area of B B dash C dash C. So now one by one we will write the formula and we will solve to find the area of triangle ABC. So area of triangle ABC is equals to, for writing area of trapezium B dash B A B, sorry B dash B, sorry B dash A dash A and B. So we can write half into sum of parallel sides into height. Sum of parallel sides, that is B dash, length of B dash is going to be y2 because because coordinate B has the coordinates as x2 comma y2, so B dash is going to be y2. So length of B dash is y2 plus length of A dash A is going to be y coordinate of point A, that is y1. So y2 plus y1 multiply by height of the trapezium, that is A dash B dash. So we know that this much portion is going to be x2 and this portion is going to be known as x coordinate of point A, that is x1. So what we need is A dash B dash, which is difference for x1 and x2. So basically we will subtract x2 from x1. So we will subtract x2 from x1, that is x1 minus x2 is going to be length A dash B dash, which we require here as height. So we have written the area of trapezium, first trapezium. Now we are writing area of second trapezium, that is half sum of parallel sides into height. Sum of parallel sides is of A dash A is going to be y1 plus sum of parallel sides C dash C is going to be y coordinates of point C, that is y3. So y1 plus y3 multiply by height of this trapezium, that is A dash C dash. What we will do, we will subtract x coordinate of A dash from x coordinate of C dash. So x coordinate of A dash is x1 and x coordinate of C dash is x3. So x3 minus x1 is going to be the height for trapezium 2. 2 means A dash C dash C. Similarly, we will subtract trapezium, area of trapezium B dash B C C dash, that is half into sum of parallel sides. Length of B dash is again y2 plus length of C dash C is going to be y3. Multiply by height of trapezium, this one. So this is going to be B dash C dash, which means we will subtract x coordinate of B dash from x coordinate of C dash, that is x3. x3 means this portion minus x2 means this portion. So we will be getting B dash C dash. So here x3 minus x2. We will simplify it to find the area of triangle ABC. So let's do it. Taking half as a common, we will multiply the brackets. We will be getting as x1 y1 y2 minus x2 y2 plus x1 y1 minus x2 y1. From this portion we are getting as x3 y1 minus x1 y1 plus x3 y3 minus x1 y3. From the third portion we are getting as let's keep it in the second bracket, minus half of x3 y2 minus x2 y2 minus x2 y2 plus x3 y3 plus x3 y3 minus x2 y3. So after simplify, let's say what is going to be happen. So I'm removing this portion. So from here we can see we are getting as half of x1 y2 minus x2 y2. If anything is getting cancelled out, we will do it. x1 y2, so x2 y2, x1 y1. So x1 y1 is getting cancelled out among each other. So we have done that. x2 y1 and okay, let's write rest portions. x1 y2 minus x2 y2 minus x2 y1 minus x2 y1 plus x3 y1 plus x3 y1 plus x3 y3 plus x3 y3 minus x1 y3 x1 y3 minus, after taking this one as minus x3y2 minus x3y2 minus minus plus x2y2 minus x3y3 minus minus plus x2y3. So we got this one. So now we will see if some terms are getting cancelled out to each other. So x1y2 x3y2 is getting cancelled to none of the above. x2y2, so we are here x2y2 and here also x2y2, so this will get cancelled out. Similarly, if we can see anything else, x3y3 plus minus, it will be cancelled out. We will simplify to next level. So what we have is x1 y2 and another term is any term related to x1 y3. So we will take this one and this one and we will write x1 common, then we can write y2 minus y3. Again x2 y1 and another term related to x2 is x2 y3. So we will take x2 as common, we can write y3 minus y1. So this has already been done, this has been done. What is remaining is x3 y1 and x3 y2. So we are taking x3 as common, from here we are getting y1 minus, from here we are getting y2. So this is the final result which we were trying to achieve. So finally we got the result. So what we have got result is, so we got area of triangle ABC as, this is equals to area of triangle ABC. Area of triangle ABC is going to be this one. Half of, we will apply modulus also because it is area, so area cannot be negative. So after calculating the after done with the calculation, we will take modulus so as to make the area positive, because area is not going to be negative. So we have got half of x1 multiplied by x2 minus y3 plus x2 multiplied by y3 minus y1 plus x3 multiplied by y1 minus y2. Also, if you will observe these terms, you will see that it is finding kind of periodic cycle, like x1 y2 y3, x2 y3 y1, so x3, after that y1 y2. So basically this is rotating like x1 y2 y3. Similarly afterwards x2, so after 2 we will be getting as y3 and y1. Similarly after x3 we are getting as another term, after 3 is going to be 1, so y1 and y2. So in this way it is kind of following a pattern. So it is easier to memorize the formula, because we are going to have this formula using very frequently in later cases also. So let's have some problem. Also we can write this formula in terms of determinant also, which is going to be very much convenient to remember also. It will remove our half of the headache to revise the formula. So in terms of determinant, what we can write is as area of triangle ABC is going to be written as half of determinant x1 y1 1, x2 y2 1, x3 y3 1. After that we will provide modulus again, so that our area cannot be negative. So this is the same as this one. So this formula is going to be written as this, in this way also. We will what we will do is we will revise this formula. We will memorize this so as to use in the formula whenever required to find the area of triangle, whenever we have the coordinates of all the points of a triangle. So half of determinant of x1 y1, the first quadrant, first 1. So this row is going to be equal to 1 1 1, this column. So basically x1 y1, this is going to be first point, second point, third point, followed by third column is going to be always 1. All the terms of third column is going to be 1. So this is the way to revise the formula, to memorize. And how we have achieved this, we have seen the derivation part. So now we will apply our formula to find some of the area of triangle after when we are having some certain conditions. So let's discuss some problems. So our first question is something looks like this. So find the area of triangle ABC whose coordinates are point A is 3, 2, point B is 11, 8, and point C is 8, 12. So we have all the three coordinates of a triangle ABC and we need to find the area of this triangle. So very basic, we will apply the formula. So we know, we have just derived to find the area of triangle ABC, that we know that in terms of determinants, what we can write it as half of x1 y1 1 x2 y2 1 x3 y3 1. After that we will take modulus. So we will apply the formula and we will see the result, how what we are getting. So x1 is 3, y1 is 2 1, x2 is 11 8 1. Third coordinates are 8 12 8 12 1. So we know very well how to solve the determinants. So we will use the method of solving determinants here. We will take 3 multiply by removing this column, this row, we are getting this one. So 8 multiplied by 1, that is 8 minus 12. Hoping that you know how to solve the determinants. So now minus 2, this term 11 minus 8, 11 minus 8 plus 1, that is 12. 11 multiplied by 12 minus 8 multiplied by 8. After solving, let's see what is going to be the result. So 3 multiplied by, that is minus 4, minus 2 multiplied by 3 plus 11 multiplied by 12, that is 12 times 12, carry 1, 13, minus 8 8 just 64. So we will simplify it. Again we are getting half of, from here we are getting minus 12 minus 6 plus 2 minus 4, that is going to be 8, carry 2 minus 6, that is 6. So this is going to be happen. So half of minus 18 plus 68 is equals to half of half multiplied by, removing 18 from 68, we will be getting as how much? So we will be getting 50. So this is going to be 25 square unit. This is the answer. So area of triangle ABC, where coordinates A, B and C are given as 3, 2, 11, 8 and 8, 12 is going to be 25 square units. We have nothing done very much anything rocket science here. We have just applied the formula. We know the formula of triangle ABC. Whenever we know the coordinates of triangle ABC, we have half of determinants of x1 y1 1, x2 y2 1, x3 y3 1. We have applied the formula. We have put the value which we have given. So just solve the determinants. We got the answer 25 square units. So moving towards the next problem. So we have second questions. Find area of triangle having midpoints of its sides at 2, 1, minus 1, minus 3 and 4, 5. So basically in this question we haven't been provided coordinates of its sides. Rather than we have been given coordinates of midpoints of its sides. So let's understand the problem first. We have, let's say we have triangle ABC. In this case we have been provided the midpoint of side length AB. Let's say this is 2, 1. Let's say point D 2, 1. In this case let's say BC is minus 1, minus 3. Similarly midpoint of AC is 4, 5. So let's say DE minus 1, minus 3. Let's say this point is E. This is F. So we have been given the coordinates of D, E and F. These coordinates have been given and we need to find the area of triangle ABC. So if we will apply the formula which we have just studied, we will be getting the area of triangle DEF, because the coordinates are coordinates which have been given are the coordinates of triangle RDEF, and this will be giving area of this much portion only. So by anyhow, if we will be able to create any relation between area of triangle DEF and area of triangle ABC, then similarly we can write the we can find the area of triangle ABC, because we can easily find the area of triangle DEF. So based on that we can find the area of triangle ABC also. So what can be the relation? Let's say let's define the relation. What can be the possible cases are here. So let's say we have triangle ABC. So we have triangle ABC and we have been given the midpoints. So let's say this is the midpoints. So we have A, B and C. So we know by midpoint theorem that if this is D, E and F. So we have already studied that if we have midpoints in two alternative sides, then this DF is going to be half of the side length BC, as well as DF is going to be parallel to side length BC. This we have already discussed. So we know if we can apply congruency in triangle ABC, in triangle ADF and triangle ABC, we can clearly see here that angle A is going to be the common angle in between in triangle ADF and triangle ABC. Angle A is common, and also we know DF is parallel to BC, so this angle is going to be equals to this angle. Similarly, this angle is going to be equals to this angle, because corresponding angles are by the corresponding angle we can say angle ADF is equals to angle ABC, because DF is parallel to BC. So we can clearly see that triangle ADF is similar to triangle ABC. So we know triangle ADF is similar to triangle ABC. So what we can write is this triangle are similar. So what other thing we can write here is, let's say so basically this is midpoint E. So if you will draw the altitudes from here, we will be getting M1 as well as M2 here. So M1 is the altitudes for triangle ADF and AM2 is the altitude for triangle ABC. Similarly, we can draw altitudes for triangle DEF as from passing through vertex E. Let's say this is M3. Since we have seen here triangle ADF is similar to triangle ABC, so by CPCT, that is congruent parts of congruent triangle, sorry, corresponding parts of congruent triangle, so we can write AM1, since DF is parallel to BC and it is half of it. Similarly, altitudes will be also in the same ratio. So what we can write here is, from this, since this is similar, so we can write DF upon BC is equals to is equals to AM1 divided by AM2, which is going to be 1 by 2, because we know DF is half of side length BC. Similarly, we can write AM1 is going to be half of AM2. Also, we can clearly see here, we know DF is parallel to BC, and M1, M2 is also altitudes. Similarly, EM3 is also altitudes for triangle DEF. Since we know that, since M1, M2 is equals to M3E. So if we will be able to find the altitudes of triangle DEF, so we can be able to write the area for triangle DEF. How we can do that? Let's see here. So to write area of triangle DEF is equals to half into base. Base is going to be DF. Half base into height. Height is M3E. So this is area of triangle DEF, half into DF. In terms of DF, in place of DF, what we can write? Half of BC. We can write it as half of BC. Similarly, in place of M3E, we can write it as M3E. M3 is equals to, since M3 is equals to M1, M2, sorry, M3 is going to be equals to M1, M2, and this is equals to AM1, sorry, this is equals to AM1. So AM1 is going to be, we can write here half of AM2. So from here we can write AM1 is going to be half of AM2, and AM1 is equals to M3E. So we can write it as half of AM2, sorry, half of AM2, half of AM2. So from here we can clearly see that half of, we can remove half and we can write BC into AM2, which is equals to 1 by 4 into 1 by 2 into BC into AM2. This is nothing but, this portion can be written as area of triangle DEF is equals to half of, sorry, 1 by 4 which is equals to 1 by 4 times area of triangle ABC, because this portion is area of triangle ABC. Clearly we can see here BC is a base and AM2 is a altitudes for triangle ABC. And so finally we got relation as area of triangle ABC is equals to 4 times area of triangle DEF. So now we can be able to find the area of 4 triangle DEF. Afterwards we will multiply by 4 to get the area of triangle ABC. So how we got the relation here in terms of the area of triangle DEF and area of triangle ABC? We have to find area of any triangle, we need to find its base as well as its altitudes. So in terms of BC, we have already known the DF, that it is going to be half of BC. What we have to find is altitudes of triangle DEF and ratio of altitudes of triangle DEF and altitudes of triangle ABC. So we know that by corresponding parts of corresponding triangle, that if base of triangle DEF is going to be half of base of triangle ABC, similarly altitude is also going to be half of half of altitudes of triangle ABC. So we have used that result, and finally we got to find the area of triangle DEF. We have replaced DF and M3 in terms of base and height of triangle ABC, and we got to know that area of triangle ABC is going to be 4 times of area of triangle DEF. So we will use this result. Now we will find the area of triangle DEF. How we can find that? We know we have been provided coordinates of triangle DEF. So we will use the formula and apply the formula to find the area of triangle DEF. So we know area of triangle DEF is going to be half of, we will apply modulus also. So half of first coordinate is 2, 1, 1, second coordinate is -1, -3, 1, third coordinate is 4, 5, then 1. We will solve it. Half of 2 multiplied by -3, -5, -1 multiplied by -1, -4 plus 1 is multiplied by -5 plus 12. So we will solve it. So here we are getting -8 multiplied by 2, that is -16, -5, -1 plus 5. From here we are getting +7. After solving it, we are getting 7 plus 5, 12. That is going to be 12 minus 16, that is -4. It is going, we will take modulus here. It is going to be modulus of -2, that is equals to 2. So finally we got to find the area of triangle ABC is area of triangle DEF is going to be equals to 2. So we can write here area of triangle ABC equals to 4 times area of triangle DEF, that which is equals to 2. This is going to be 8 square unit. So the main portion which I wanted to tell you is that in terms of if we have been provided midpoints of side lengths of triangle ABC, so the area formed by the midpoints of triangle ABC will be occupying 1/4 area of the complete triangle that we have already seen here. We have derived this, and afterwards we have applied this to find the result for this problem. So finally we got 8 square unit as the area of triangle ABC after finding area of triangle DEF, which was equals to 2 square unit. So moving towards third problem. So here we have our third problem, that is find area of triangle formed by the points. We have the first coordinates as x, x minus 2, second coordinates as x plus 3, x, and the third coordinates as x plus 2, x plus 2. So very basic. We will just apply our formula, that is area of triangle ABC is equals to half of determinants of x1, y1, 1, x2, y2, 1, x3, y3, 1. Apply modulus overall the result. So now we will solve it. 1 by 2 of first coordinates are x, x minus 2, 1. Second coordinates are x plus 3, x. Here will be 1, x plus 2, and so after solving it, we are getting as x multiplied by just simple calculations are there to get result of this problem. X multiplied by x minus x plus 2 minus x minus 2 So we will be getting it as x plus 3 minus x plus 2, x plus 3 minus x plus 2. So minus x minus 2, I have just written it in one go. So here x plus 3 multiplied by x plus 3 multiplied by x plus 2 minus, this is 1, minus x multiplied by x plus 2, x multiplied by x plus 2. This kind of calculations are there. So we will do calculation and find the answer. From here we are getting half of x minus x got cancelled out, so we will just simply simplify it and write that is minus 2x. From here, from the first term we are getting as minus 2x. From here we are getting minus 2x because x got cancelled to x. Remaining part is minus 2. So minus 2 multiplied by x, that is minus 2x. From here we are getting in bracket x got cancelled to x, coming plus 1. So it is minus of x minus 2 only. From third one we have to solve it. Plus x square plus 5x plus 6 is being subtracting x square plus 2x. So we need to solve it. From here we are getting minus 3x plus 2 plus x square got cancelled to x square. We are getting 5x minus 2x, that is 3x plus 6. After solving we are getting 3x got cancelled to 3x. Here we are getting 8, that is equals to 4 square units. So it is the result which we are getting is, which is independent of x. It is not depending on the value of x. We can replace any value to x, we will be getting the same result, that is 4 square units. Suppose we are giving x as any constant term, let's say 4. So we will replace x with 4 to all the coordinates which we have been provided. We will be getting the same result, that is 4 square units. It is not going to change because it is not depending on variable x. So we have, this problem was just basic. We have to apply the formula which we have studied, that is area of triangle ABC is going to be half of determinants of x1 y1 1, x2 y2 1, x3 y3 1. We have put the values which we have been provided and we solved it to get the result 4 as our answer. So till now we have done all the discussions which we have been planned to do in today's lecture. So hoping that you will enjoy the lecture. You have already enjoyed, if you are here you have already enjoyed the lecture. So meeting you in the coming lecture with another topics. Till now just enjoy, just solve all the problems which have been discussed in the class, all the concepts which we have discussed today. Revise it thoroughly and go through once, twice, thrice till you are not able to understand it. Make all the concepts clear, because once you are clear with the concept, then only you will feel confident to solve more problems, more and more number of problems. Then only you will get more confidence to solve much problems, and you can score good marks in your coming examinations.